Hello, everyone. We are Group 3, and we are pleased to present our research titled Research on the Spatial Characteristics and Emotional Experience of Urban Pet-Friendly Spaces based on RedNote data, a case study of Shanghai. This study explores the intersection of urban geography, sentiment analysis, and the burgeoning pet economy within one of China's most dynamic metropolitan environments. Our presentation is structured into 6 comprehensive sections to provide a logical flow of our investigative process. We will begin with the background. We are currently witnessing a profound socio-cultural phenomenon known as the pet revolution. This represents a paradigm shift in the identity of pets. They are no longer viewed merely as property or domestic animals, but have ascended to the status of integral family members. This emotional bonding has transitioned pets from the private domestic sphere into the public life of the city. Consequently, there is a burgeoning spatial demand from pet owners who seek to travel with their companions and share urban experiences in pet-friendly environments. Despite this surge in interest, a significant tension exists between demand and supply. While third places, such as cat cafes, pet-friendly shopping malls, and specialized parks are proliferating, the supporting infrastructure remains highly localized and spatially uneven. These structural limitations hinder the development of a positive emotional bond between pet keepers and the urban environment, creating a gap in the inclusivity of urban public spaces. The pet economy is increasingly driven by emotional value. User-generated reviews and experiences shared on social media platforms are exerting a powerful influence on the industry's trajectory. To understand the spatial distribution of these spaces, we must analyze the influence of socio-economic factors, including local economic vitality, population density, and infrastructure accessibility. Traditional methodologies for assessing emotional responses to urban spaces have relied heavily on self-reported surveys or questionnaires. However, these methods are often constrained by limited sample sizes and are vulnerable to subjective memory bias. To address these limitations, our research utilizes geotag social media data to capture public sentiment efficiently across a massive scale. By employing natural language processing (NLP), we can transform unstructured text into quantifiable sentiment scores to measure intangible emotional well-being. Furthermore, we deploy regression analyses, such as ordinary least squares, Olsand geographically weighted regression (GWR), to quantify how built environments influence positive emotions across varying geographic scales. Our study focuses on Shanghai's 7 central urban districts. We chose this boundary because our crawled data is mainly concentrated in the urban core. Our primary data source is RedNote Xiaohongshu, a premier lifestyle urban platform. Unlike traditional social media, RedNote provides emotion-rich textual content and real-time spontaneous feedback from users. Crucially, it offers quantifiable engagement signals such as likes, shares, comments, and saves, which allow us to gauge the public resonance of different pet-friendly spaces. Using Python web scraping techniques, we targeted pet-related experiences in Shanghai, using specific keywords, Shanghai pet-friendly park, shopping mall, and accommodation. This process yielded 3,308 raw posts. Following deduplication based on Note IDs and manual cleaning to remove irrelevant content, our final dataset comprised 2,259 high-quality notes. To provide a comprehensive socio-economic context, we integrated multi-source secondary data. This includes population counts from WorldPop at a 100-meter resolution and point-of-interest data from OpenStreetMap, covering restaurants, parks, shops, and pet stores. We also utilized nighttime light radiance from NPPVers at a 500-meter resolution as a proxy for economic activity. These variables serve as the explanatory factors in our regression analysis. We evaluated our data quality across 5 dimensions. Volume is represented by thousands of user-generated notes across 7 districts. Velocity is reflected in the real-time nature of social media updates. Variety encompasses 4 data types across 3 formats: unstructured text, spatial vectors, and remote sensing rasters. While we acknowledge veracity challenges such as sample bias and informal tags, we addressed these through a rigorous cleaning pipeline. Finally, the value of this data lies in its ability to inform policy recommendations and site optimization strategies for urban planning. This is our workflow. It moves from raw data collection through location processing, index construction, spatial analysis, and finally, driving force analysis. Because raw social media posts contain informal location references, we utilized the Qwen 2.572b Instruct Large Language Model, LLMTO extract, named place entities. We selected this model for its superior Chinese language comprehension and cost-effectiveness for batch processing. These locations were then geocoded using the Baidu Maps API to obtain precise coordinates. Finally, each location was classified into one of three functional types: commerce, nature, or accommodation, allowing for a type-stratified spatial analysis. To quantify the pet-friendliness of each location, we constructed a multidimensional index, PFI. The formula is here. Sentiment scores were generated using SNOWN-LP, a library specifically trained on Chinese corpora. Pet relevance measures how pet-centric the content is by calculating the ratio of pet-related sentences. The engagement index is a weighted sum of likes, shares, comments, and saves, log-transformed and normalized for comparability. Our spatial analysis employs three primary methods. First, kernel density estimation generates a continuous surface to reveal spatial hotspots and cold spots of pet-friendly potential. Second, global Moran's eye measures the overall degree of spatial clustering. Third, local indicators of spatial association identify statistically significant local clusters, such as high areas and spatial outliers at the individual location level. To analyze the underlying drivers of these spatial patterns, we utilize a three-step statistical pipeline. We start with Spearman rank correlation to examine relationships between the PFI and 8 explanatory variables, as our data is not normally distributed. Next, we perform principal component analysis to address multicollinearity, retaining components that explain the majority of the variance. Finally, we apply OLs to identify global drivers and GRAR to reveal spatial heterogeneity in these relationships across different districts. Moving to our results, the KDE maps reveal distinct spatial patterns for each category. Commercial pet-friendly activities are highly concentrated in the urban core, forming a clear hotspot pattern driven by agglomeration, effects, and accessibility. Natural-related activities are more dispersed, with smaller hotspots associated with specific green spaces in waterfront areas. Accommodation exhibits moderate clustering, extending along major urban corridors. In total, we identified 1,201 commercial, 176 natural, and 71 accommodation-related pet-friendly locations. The Moran's eye analysis confirms these observations. Commercial activities show clear spatial clustering, z-score 4.61, p and lt 0.0001, with high clusters in the urban core. Natural-related activities also show significant but weaker clustering. Interestingly, accommodation activities were statistically insignificant, p and gt 0.05, indicating an absence of meaningful spatial clustering and suggesting that these locations are chosen based on individual preference or flexible land use rather than spatial dependence. The Spearman correlation results indicate that pet-friendly locations are positively correlated with most variables, particularly restaurant and shop counts. R is approximately equal to 0.39. This suggests that these spaces are closely linked to areas of high human activity and consumption. Conversely, natural factors show relatively weak relationships. Notably, there is a negative correlation with the distance to car parks, highlighting that accessibility is a critical determinant for the viability of pet-friendly venues. Overall, these spaces function more like urban service amenities than ecological features. Our PCA effectively reduced our 8 explanatory variables into 6 principal components. PCA1 represents commercial intensity, dominated by restaurant and shop counts. PCA2 and PCA3 capture socioeconomic and service availability dimensions, such as population and economic proxies. PCA4 and PCA5 are associated with built environment constraints and distance-related factors. This simplification allows us to understand the complex structure of urban influences on pet friendliness. The OLS regression model demonstrated robust performance with an R of approximately 0.67 and no multicollinearity issues. All VIF is approximately equal to 1. PCA1 commercial intensity was identified as the primary driver with the largest positive coefficient. However, the significant Kernker-BP statistic suggests spatial variability in these relationships, confirming that a global OLS model alone is insufficient to capture the full picture. A comparison of the standardized residuals between OLS and GOR highlights the superiority of the local model. The OLS residual map shows clusters of positive residuals in the city center, meaning the model underestimates the observed pet-friendly activity there. This implies the presence of unobserved local drivers like high footfall or mixed land use. The GDUR model significantly reduces these residual clusters, accounting for these local variations more effectively. The GDUR model achieved an R of 0.93 and a lower AICC value compared to the OLS model, indicating a significantly better fit. While OLS identifies what matters on average, GDUR reveals where it matters most. For example, GWR shows that the influence of commercial intensity is significantly stronger in clusters along the Hongspiu River compared to other urban centers, reflecting the city's unique central peripheral structure. In conclusion, pet-friendly locations in central Shanghai are primarily driven by commercial intensity rather than natural environments. These spaces are deeply embedded in everyday urban life and socio-economic dynamics. While population and pet services are important, they often operate at the neighborhood scale, which limits their explanatory power at the broader district level. Ultimately, the distribution of these spaces reflects patterns of urban development, intensity, and daily consumption habits. Our study acknowledges several limitations, including platform bias in social media data and the fuzzy nature of geocoding in formal locations. Additionally, the use of proxy variables and the selection of spatial scales can influence the interpretation of causal effects. Despite these challenges, our findings offer critical implications for urban planning. Planners should prioritize commercial and mixed-use areas for pet-friendly development and focus on improving accessibility to enhance these environments. Finally, integrating pet-friendly features at the community level is essential for aligning with the actual scales of daily urban life. And that's all for our presentation. Thank you for your attention.